Hey guys, so today we're going to be writing expressions, but we're going to be doing it from word problems. So we're going to be giving those expressions a little bit more meaning. So the first thing we need to do is kind of fill in some information. So first, we're going to read carefully. We're going to identify the key words, okay? Second, we're going to choose a variable, remember that's the letter that we use, to represent the unknown amount. So the unknown quantity, the unknown number, and we're going to define it. Third, we're going to write the expression. So guys, feel free to pause this video if you ever need a chance to catch up, write anything down. So we're going to go ahead and we're going to jump right in. So Mike drives 1/3 the distance that Karen drives to work. Write an expression to show the distance Mike drives to work. Okay, so Mike drives 1/3 the distance that Karen does. Do we know what Karen drives? No. So that would be our variable. That's the part that we don't know. That's the unknown amount. So the unknown amount is the distance that Karen drives, and we know that Mike drives 1/3 of that. So we're going to define this. D is going to represent the distance Karen drives to work. Okay, so he drives 1/3 the distance that Karen does, so we're going to have 1/3 the distance. So 1/3 times the distance is going to give us what he drives to work. And that's all it's asking. We just got to write the expression. So for number 2, Mr. Green's math class is planning a trip to the IMAX theater. It's going to cost $400 for the school bus, and the price of a ticket is $13 per person. Write an expression to determine the total cost. So it's going to cost us $400 for the bus, and the price of a ticket is $13 per person. So we know that the number of people will change the cost. So the number of people will change the cost. So the number of people will change the cost. And we know that a bus is $400 and a ticket is $13 per person. So $13 per person. So we're going to define P is going to mean the number of people, because we do not know that. Number of people, okay? So we're going to have 400 for the school bus, so we know we're going to have the bus, and would be plus the bus plus the cost of people. So now we can fill this in. So the bus cost us $400 plus how much per people? We don't know. It would be $13 times however many people went. So 400 plus 13p. All right. Number 3. So Sean bought a box of popcorn for $4 and bought 3 medium drinks. So write an expression to represent the amount of money that he spent. Okay, so we want to know the total amount. So we know that Sean bought a box for $4 and we have 3 medium drinks. Okay, now if we're going to be finding the cost, do we know how much those medium drinks cost? No. So we want to know, what is the cost of drinks? What is the cost of drinks? Okay, so what is the cost of drinks? So we can represent C equals cost of medium drinks. Okay, so what does it give us? It gives us popcorn is $4, so we know that. Popcorn is $4, and we know that we need 3 medium drinks, but we don't know how much those cost, so that's going to be our variable. So we know we're going to be paying for popcorn plus the cost of the drinks, as we're finding our total, which would be to add. So popcorn was $4 plus Do we know what the cost of the drinks is? No, but we know we bought 3 times whatever the cost is. So 3 drinks times whatever the cost. So 4 plus 3C. All right, number 4. So Sean's father is working on a crew that will build a skyscraper. He found out that each story is 13 feet tall. So we're going to write an expression to represent the height of the skyscraper. Now, we know that each story is 13 feet tall, but do we know how many stories there are? Nope. So we don't know how many stories there are, so we're going to use S and make sure it looks like an S and not a 5. So S is going to represent the number of stories, because we don't actually know how many stories there are, so the number of stories. But we do know that each story is 13 feet. So we would do 13 times however many stories we have. That one's pretty plain and simple. All right. Moving on to the back. Remember, guys, you can pause if you ever need to. So the rental fee for a bike is $10 plus, so we know we're going to have some adding, $3 for each hour the bike is used, plus $3 for each hour the bike is used. Write an expression to determine the total cost to rent a bike. Okay, so we know we're going to be paying $10 plus we have 3 for each hour. Okay, do we know how many hours we have? No, this is going to be our variable because that's the unknown. We don't know how many hours. Okay, so let's represent H for number of hours because we don't know that. So we have H as the number of hours. It does tell us that it's going to be $3 per hour, however many hours that may be. Okay, so we know we're going to have to pay our rental fee. So we're going to go up, we're going to pay the rental fee. And, because we're going to plus, and the number of hours rented. Because we have rental fee plus hours rented. So we have a rental fee of $10 plus $3 for however many hours we rent it. Because that one can change. So our number of hours can change. All right. Tommy earns $4 for every table he serves plus 20% of the total customer order. So now we're going to write an expression to represent the amount of money he earns for one table. So we earn $4 for every table plus 20% of the total customer order. Okay, now, do we know what that total customer order is going to be each time? No, so that's going to be the part that changes. That's going to be our variables. So we have the total customer amount we can represent with C. Total customer amount. And guys, remember, you can use whatever variable as long as it makes sense. And that we define it. So C, the total customer amount. Okay, now we know that we are going to be paying the $4 for every table plus the 20%. Now, guys, remember earlier this year we learned that we cannot write a percent. We can't use a percent in a problem, right? Remember, that's just kind of a way to write it, but there were other ways to represent it. So we know that if we're going to rewrite percent, it's always out of 100. So we would do 20 out of 100. And we could simplify that, and that would equal 1/5. But does it really make sense to keep it as 1/5? Not in terms when we're talking about money. So what could we do? If it's in the form of a fraction, remember we can make this into a decimal. So the top number always goes in the house, top dog always in the house. So 1 divided by 5. So we can't do that. So we would have to add a decimal into 0. Okay, so 5 went into 1 0 times, 5 goes into 10 2 times, leaves me with 10, 0, awesome. Okay, so this is going to equal 0, and so that's about 20 cents. Okay, so we have 0.20, which would give us the same thing as 20%, so we have 20% is the same thing as 0.2. All right, so we know for sure he's going to get paid $4 no matter what. And whatever 20% of the total bill is. Remember, the C is our total bill. We don't know what the total bill is. So whatever 20% of the total bill is. All right, and the last one. A camp leader figures that she needs 1 tent for every 3 campers, plus a tent for herself. So write an expression to represent the number of tents needed. So we need 1 tent for every 3 plus a tent for herself. Okay, so plus a tent for herself. So for every 3 campers, do we know how many campers we have? Nope, we do not. So that's going to be our variable. Okay, so we're going to represent campers with the C. C equals number of campers. Okay, so we have the number of campers divided by 3. And I need 1 tent for herself. So 1 tent for every 3 campers plus 1 for herself. So the number of campers divided by 3, that would give us how many per tent, plus 1 for herself.